Hello, welcome to this introductory video for my CNC project. This is a new project that I've started, and the aim is to make a fully functioning 3-axis CNC milling machine. As a bit of background about the project, I purchased a TIG, or Petal as it's known in the UK, micro lathe, and as soon as I had it I was looking for ways to improve it. I came to the conclusion that the milling attachment provided with the lathe was alright for small workpieces, but was not ideal for the sort of milling I was wanting to do, and therefore I had to find a solution to that problem. I thought it would be interesting to have a try at making my own milling machine. So why would I want to make a small milling machine from scratch? Well, firstly, the ones you can buy are not ideal for my purposes, as it says they're either too flimsy or too expensive. I also like the ability to be able to fully integrate a CNC system into what I'm making without having to work around the existing limitations of a manual machine. This also means I can fit recirculating ball screws and recirculating ball guideway rails. Another good reason is that I'm currently studying at a technical college, and there is a nice free selection of bar stock materials which I don't pay for, so that's good on that front. And it's also a really good learning experience for me to learn about principles of accuracy and precision and build my own machine. Going back now for a bit of history, last summer I was at a loose end, really, in between stages of education, and I was really looking for some sort of project to design and have a go at maybe trying to make. I've been looking at Deckel FP1 type milling machines. Also, they're made by Schaublin and other such companies. They're an excellent machine, very well regarded. They are, however, too big for my current workshop size, and they're also horrendously expensive if you can find them, which is not always the case. I then came across the Aciera F1 type of milling machine, which was very much more the sort of size I was looking for. Again, the problem with that milling machine is it is Swiss made. It's made to a very high standard, but it's also made to be quite expensive. They don't manufacture them anymore, and they're very much sought after by watchmakers and other people involved with such high levels of precision that it's not in my capability to consider purchasing one. So then I spent many hours drawing up my own version of a milling machine very similar to the Aciera F1 on paper, using a pencil and a ruler. It was a long and drawn out period of time spent that it was a useful learning experience, but it wasn't really any use to me later on. It was good to get the initial concepts thought through. The initial design, of course, didn't contain any of the CNC parts that you'll see coming up soon, but it allowed me to think about how I would make some of the components and what I would need in order to make them. While I was searching through the realms of the internet looking for Aciera F1 milling machines, I came across a few that had got a CNC system attached to it. I'd never really thought about the fact that you could have a small CNC milling machine. I'd always seen the large vertical machining centres and thought that was all there was. That was an interesting step in the design process. I was able to consider using technology that's really become increasingly available over the past few years to make a much more versatile machine without having to make hundreds and hundreds of attachments for it. After a long time sketching in my notebooks and rapidly evolving my ideas of what a suitable milling machine would look like, I decided that I had to get a better way of drafting my sketches, really, because each time I made a new modification, it was taking me too long to redraw every single drawing in order to fit the new specification. I invested a few hours in learning a CAD software called Onshape. I found it to be very useful. Admittedly, my computer does struggle, as you can see on the screen, loading data and graphics for such a large project. As the parts come up on the screen, you will see that there's been a pretty considerable jump in the design from the initial construction of the Aciera F1, which was made predominantly using castings. I don't have access to a cheap source of castings. Can't do them myself yet. So I redesigned the whole machine to work off commonly available bar stock sizes, both in steel and aluminium. I don't have any pictures or video of the actual machine that's been built at the moment for the purposes of this video, but I am able to give a complete walkthrough of the CAD document that I've designed it all in. So firstly, we have the foundation of the machine column shown in blue and the base shown in grey. Both these parts are made out of aluminium bar stock. They were offcuts from CNC projects that had not gone quite to plan. I was just able to fly cut all the excess off. They weren't wide enough to fit the linear motion components I was looking for, so I had to make two steel plate adapters. It's just coming up here. One in the y-axis at the top in blue and one in the z-axis in yellow. We're just showing here I didn't design all the holes necessary into the CAD document. It was hard enough drilling them all, let alone having to model each of them. We now move on to my semi-detailed models of the linear motion rails that I'm using. Again, I didn't model more than I needed to, so each axis in this case has one rail and one sliding block, although in the finished article there are two rails on each axis and 4 sliding blocks, just to provide the amount of rigidity that I was looking for. Further down, this is now the overarm of the milling machine, the y-axis slide. This is where the spindle mounts to. You can see we have a rib in the back and a dovetailed block at the front. Out the back there will be a stepper motor mounted, again just showing the rib. This is the only piece that was fabricated. It was all welded together, mainly because I didn't want to machine out the whole part. Now just coming up, we have the horizontal to vertical adapter. This could be used as a horizontal milling machine, I'm not so sure at the moment whether I will, but this is just a block with a dovetail on the end, and it allows some adjustment for the tramming of the head in order to produce accurate workpieces. As we go down further, we get to the knee of the milling machine. So this is the component that slides up and down on the z-axis. There's plenty more holes in there for more linear slide rays. There is a slot cut through the middle for the ball screw to sit in, so it doesn't protrude too far. We just pull up the x-axis linear slides. I modelled both of them in here, not quite sure why, but I did. As we move now further around to the other side, we can see the z-axis ball screw location. Now, I didn't think it was practical to put it down in between the sliding rails. There just wasn't enough room on the design, so I mounted it at the side. It's a slightly unusual configuration, but I thought a lot of lathes have their lead screws mounted off down to the side. It can't be too bad. And then finally, for the z-axis motion, we have the ball nut and the ball nut housing, and then a small adapting bracket in dark grey that can be seen that attaches to the knee and transfers the motion across. Just adding the sliding blocks for the x-axis going across on the knee before we can introduce the table to the design. Just showing where the table connects onto. The table in this case was made from a 6-inch angle plate. It It's just seemed easier to purchase the angle plate than it was to either make a welded construction or try and mill down some rather large piece of hot rolled angle steel into the correct shape. Also, the bonus of an angle plate, it comes pre-machined to the A, the correct size, and also B, to a pretty good squareness tolerance, which is what I needed in this application. When you look in between the linear slides and the table, there is a gap. This gap is in place to allow enough clearance just there for the ball screw, which is the same ball screw as all the other axes. Smaller ball screws were available, but the cheapest and the best value ball screws were in the sort of 12mm diameter category. So I had to make 2 spacer pieces in order to get across that gap. And lastly, for this stage of the drawing, we get to the spindle. Now, this spindle I have not made myself. It's the spindle off the Tide lathe that I own. I just thought it would be a good use of what I had to use it for this project. It's not modelled to give any real sense of detail. It's just to give the placement of, for example, the spindle motor, which has just come up in blue. And the spindle motor is mounted on a bar which is attached to a T-slot in the front of the lathe spindle, which is in this case now going to be a mill spindle, and it can swing out for tensioning the V-belt, which drives the spindle.